Hi, my name is Hannah Keeler. I will be one of the three participants you'll hear from today from Team 2 regarding the A2 team project. Our team has elected to focus in on PG&E, or Pacific Gas and Electric, which is a local utility here in Northern California. They're one of the largest utilities in the United States. More specifically, we'll be looking at a process improvement plan for PG&E's transformer crisis. They have not had transformers for many years. This affects not only our nation's economy, but a number of innovations and upcoming developments. So we're excited to dive in. Again, you'll hear from three team members, myself, Hannah Keeler, Jorge Gonzalez, and Ben Brokey. Our proposed agenda is as follows. We would love to touch on who PG&E is if you're not familiar, why we should care about the transformer shortage, and why this is just so critical to our nation's economy and overall innovation. We'll touch on the organization of PG&E, kind of who they are and what they do, ops management challenges, a high-end view of the supply chain, or really focusing in on transformer supply chain, process selection and justification, why we're choosing this process and why this makes the most sense and has the most pain in our eyes, a detailed process diagram followed by some process improvement rationale, some revised process diagrams, and an analysis. We'll then jump into improvements on sustainability and close out with some CSR. We do have some academic references in our appendix as follows.
Before we dive in, let's look at an overview of PG&E and their systems in place and discuss the problems that PG&E are facing in their process to deliver energy to businesses and households. PG&E was founded in Oakland, California over 100 years ago. They're a natural gas and electric service utility company which provides service to most of California, as you can see in the graphic there below. They are the largest public utility company in the United States and also one of the largest private owners of hydroelectric facilities in the United States. They do also currently have an operational nuclear facility, the Diablo Canyon Power Plant, that currently produces a whopping 53% of their retail electric delivery, according to PG&E themselves. Today, the most pressing issues are transformer supply chain issues, an exponential increase in the demand for energy, a lack of coordination by stakeholders, from major clients such as Tesla or Google to government agencies in charge of housing expansion and planning. Lastly, PG&E has quite a passive approach to their future planning, which helps contribute to even larger bottlenecks and delays with transformers. We'll get into more details here soon, but first let's take a look at a brief overview of how PG&E delivers their energy. Here we have a basic overview of how energy is delivered from supplier to the end consumers. First, let's take a look at the generating station on the left. This generating station can be a natural gas system, a hydroelectric system, wind, solar, nuclear, etc., etc. My point is that it can be from one of many sources, all with a different output level and frequency. That's where the transformer there really comes into play and why they're so crucial to the energy supply chain. The transformer steps the energy up to a consistent level where it can be transmitted to a local substation. You probably have one of these not too far from where you live. Here, another transformer is required to step down the power and then distribute it to households, businesses, and other consumers of electricity. There's often even a third transformer attached to your meter at your house. So as you can see, transformers play a crucial role in the delivery of power from the source to the consumer. Now that we have a basic understanding of that process, let's take a more in-depth look at the challenges PG&E is facing with this process. I want to focus on four main challenges that PG&E has with this supply chain process. As we've seen in the previous slide, there's a heavy dependence on transformers to a point where they're critical to almost every point of the supply chain. There's also a very limited manufacturing capacity, which leads to huge delays and bottlenecks to setting up new energy stations and transfer lines, which, as we know, all need transformers. In fact, transformers require a specific steel called grain-oriented electrical steel, and that steel is only produced by one company in the United States called Clifton Valley. This makes an already strained supply chain even more delicate. There's also been an exponential growth in the demand for energy in the United States in recent years. From roughly 2005 to about 2020, energy demand in the United States stayed fairly flat. Recent technological innovations, such as electric vehicles, AI facilities, and data centers, require massive amounts of energy and have already strained the grid's capacity. To put this in perspective, a Tesla Model 3 takes around 80 kilowatt hours to fully charge. That's around the same as an average US household consumes in 4 days. Data centers alone are projected to use around 9% of the total electrical energy generated by the United States in 2030, so this trend is certainly expected to continue. PG&E also has quite an inflexible planning approach, and that can lead to massive delays in procurement. PG&E requires agreements to be executed before capacity reservations can be met, meaning that critical equipment such as transformers are not ordered until formal agreements are fully executed. There are reasons for this, such as regulatory compliance and PG&E just minimizing their own financial risk. But when wait times are often 6 months to a year, it really doesn't help the issue. It also means that the actual order for the transformers aren't placed until later in the project cycle. This can hold the entire project up as nothing can really happen without this crucial piece of the system. Lastly, the grid is in desperate need of modernization. The aging infrastructure cannot keep up with the modern energy demands. So, not only is there the issue of building newly required energy pipelines, there's also the issue of replacing existing ones as well. One more problem we have not talked about yet is the integration challenges with renewable energy sources. Energy supplies such as wind and solar can be provided intermittently and need additional storage options to be effective. Figuring out how to integrate these sources and add the required technology, such as batteries, which we'll touch on a little bit later, is a massive project in itself. But next, let's take a closer look at the supply chain for providing power to the state.
Thank you, Ben. So, as Ben was saying, transformers are very difficult to procure, and they depend on what EPC and what construction projects are being worked on. But we require transformers during all the supply chain for PG&E, for example, and other utility companies. Transformers are required every time energy is going to be matched to a line which is with which energy is going to be introduced to. So first, the supply chain starts where energy is generated. This generation includes solar, wind, geothermal, biopower, hydroelectric, nuclear, coal, natural gas, and every time electricity is generated, it's generated in different voltages. So a transformer is used to step up the voltage and increase it to the high voltage lines, where the high voltage lines cover long distances and transport the energy for long distances, and then it comes down to a substation. The substation is built of a lot of transformers, and they bring down the energy from the high voltage into a more usable voltage for your house. But then another transformer is used to introduce the energy into a local transmission line, which then another transformer is used to introduce and bring down the energy into your home through the electricity meter that measures how much electricity you're consuming. So that way the electricity company knows how much you will be charged. So we decided to bring the transformer into attention because since we require it during every step of the grid, um, it's very important that we have access and that the supply chain for the transformers is quick. Some transformer manufacturers have an average lead time of around 2 years. This means that PG&E cannot expand the grid even if they want to. So given the shortage and the lead times, significant change has to happen in order to avoid an electricity crisis. This could be in form of the grid where energy generation is closer to where it's consumed. So, for example, solar panels in your home, you generate electricity where you're going to use it. And then it could also mean investing in transformer technology and manufacturing where other types of technologies can be used to bring voltages to where you need it without the need of a transformer.
Honing in on our detailed process diagram, we've elected to break this into four separate buckets or segments, really starting with the customer. starting at the top of the funnel with their process design, looking at PG&E as a whole and what their organizational processes allow them to complete, followed by the electric EPC or the engineering procurement provider. Sometimes this can be a fancy word for the contract in that of itself. And then finally, the transformer supplier. So there's really four key buckets that really affect the availability or lack thereof of transformers. As you can see, this is a very extensive and elongated process. There's so many parts in this Visio that could really be consolidated, and critical processes that are maybe not that critical that could actually be deleted and removed or replaced with automation or increased awareness and tracking. We know that there's the majority of these buckets are actually within PG&E's control, which is very fascinating. So as we were mapping this process, we found that there's a number of items that are well within their control. Of course, there's some cases that are external circumstances and they won't be able to directly influence, like how the timing of what their transformer suppliers are working with, or the availability of raw materials, labor shortages, etc. But we did find that there was a pretty excessive amount of items that were within PG&E's direct control that we'll look into in a further slide to see how we can audit this and simplify and scale our process. Following up from our last slide on a detailed overview of what the current process is, we've outlined here a couple of key points that really stand out to us when it comes to current approach and proposed solutions. When we look at a process improvement rationale, or really a PIP, effectively what we're doing is placing PG&E on a PIP to really showcase our proposed solutions for items that we feel are just not sufficiently fighting the transformer shortage. So the current approach has a lot of delayed ordering. Transformers are ordered well after those EPC contracts are signed, after they get a PO, which makes sense. This just doesn't make sense, though, for the businesses and clients that they support. They each have different businesses, different verticals that operate on different timings. Weak negotiation power, so that EPC or that customer is really acting individually. It has really limited leverage with some of those manufacturers, which can lead to very unoptimal terms and poor pricing. We're noticing some fragmented orders. It's very choppy. Manufacturers receive very small orders versus a bulk or batch order as well. So looking at proposed solutions, our team is proposing a strategic procurement. So those bulk orders should be placed on focuses where we've got transformers that are based on aggregated project demand, which means having more conversations that are open and honest with your customers, having those biweekly touch bases with Google and Tesla, and ensuring that those do not slip off the calendar, to make sure that not only do you understand a Google or a Tesla's 2-year plan, but you understand the 50-year plan, so you can adequately discuss with your wholesalers what that means for the power demand. We recommend delivery scheduling as well. So we're coordinating those delivery schedules that align with project timelines. We know it's very costly and spatially cognizant to be able to store a transformer, a pad-mounted transformer. Nonetheless, this is not a small, easily storable piece of equipment, as we know. We're looking at improved forecasting as well, pouring heavily into our teams to ensure that we've got centralized planning that is allocated for accurate demand forecasting of transformer needs, enabling better alignment with those manufacturing capabilities. As we review our revised process diagram, we've split these again into 2 buckets, focusing primarily on future state and current state. You'll notice future state is much smaller than current state. We want to keep our new processes simple, scalable, and effective. One article that we found that was very fascinating to us as we kind of unraveled the process of why we have transformer shortages and what PG&E's role is in that process is we've got a really interesting article from CISA, which is the Cybersecurity and Infrastructure Agency in the US. They published a report earlier this year that was very fascinating on what the effects of the transformer shortage not only means for our global economy, but also means for technological innovations. So we know that this is very important, and it's why we chose to focus on this problem. So current state, what we're seeing from PG&E specifically is slow reaction times, delayed ordering, increased costs. These are just a couple of items on this list, but really mismanaged priorities with our power wholesalers and mismanagement of budgeting as well, which we've included in our appendix. They've actually nearly filed for bankruptcy, I want to say almost 3 times. Been very, very difficult for them from a year fiscally. They've had minimal upgrades forecasted unless they are funded by some of their customers. and just contractual structures, preventing them from future plannings. A lot of this is within their own organizational approval patterns and structures that is allowing them to operate this way. Other is maybe some more political explanations, but future state, our recommendation of what we hope to see as a revised process diagram from PG&E would be establishing a mission and culture around first principles thinking. We identified previously in the slideshow that they have many redundant and bulky processes that are well within PG&E's control that are not necessarily contingent on a third-party supplier or an EPC. So we really need to push from the top when it comes to fresh leadership or fresh eyes in middle management who is really pushing to work around first principles thinking to further accelerate the adoption to clean and green sustainable energy. We recommend that not only do we gain leadership priorities, but we grow lean. We centralize our planning teams. We leverage bulk purchasing, as we've alluded to a number of times, and really honing in on that established direct communication and keeping those cadences with your high value customers like a Google, a Tesla, an Amazon, and Microsoft. These folks are building data centers that are over 100,000 square feet and will require maybe 100 megawatts in some cases to be able to operationalize these facilities. So again, implement real-time monitoring systems. We need to establish a very strong NOC team who can begin to track this equipment and monitor this equipment, develop contingency plans, grow and understand, again, our customers' businesses, and improve our contractual structures. To me, to PG&E's detriment, really the most critical piece is assuming that customers' businesses are operating similar to them, which is not necessarily the flow structure. There is so much we could have put on this slide. It's amazing that we got it onto one, but this is a pretty raw analysis of what the transformer deficit looks like to PG&E on a grand scale. So first, we're going to hone in on input. So what's kind of going into that process? It's planning. It's the actual stock of the transformers, the kVA transformers. We're looking at the raw materials that are utilized, coal, uranium, petroleum, to generate this power in the first place to even allow for transformers to be an option. We're looking at how that power is generated, hydro, geothermal power generations, other machinery, manpower, or also lack thereof. We know that that can be another reason that we're seeing transformer delays. Then we're going to go into transformation of input. So kind of how this is transferring through improved planning, bulk purchases, alternative contractual structures, and forecasted reservations will be critical. Executing a lot of those CROs ahead of time without specific contractual obligations could be critical. May open up risk, but it could be a way to help catch them up to speed. And then output. What our goal here is really strategic surplus. And I really want to hone in on strategic surplus, not a surplus, of pad-mounted, pole-mounted transfers, network voltage, and then special transformers as well. And then we're looking to mitigate that need through customer education. So mandates on maxing out KVAs and PMUs. Requiring customers to max out that transformer will mitigate the need for that customer to come back time and time again. When you look at EV charging here in the Bay, if I'm utilizing Fremont, for example, mandating a customer to build 24 EV stalls out of KVA based on those PMUs is much more efficient than telling that customer, we're going to bring in a brand new service, we're only going to open up 8 charging stalls, and it's going to be effectively the same price, the same timeline, and the same cost to the customer. So critical through customer education to be ensuring how we can max out those transformers. Next, we're going to look at process design. I think one of the most important things to touch on here that we would like to recommend to integrate would be completing postmortems on their SOP or standard operating procedure. And then within process controls, efficiently and effectively meeting the demand of Northern California's largest customer base on power forecasts and enabling the utility to maintain a strategic transformer inventory.
So, what are some areas that PG&E can focus on to improve sustainability efforts? First off, as we mentioned before, the transition to green energy sources provides a bit of a challenge in itself. However, with new technologies on the horizon, expanding the renewable portfolio and leaning towards decentralized energy generation can have a huge impact overall. These can be large-scale projects like nearby solar farms, or even small-scale like having a solar panel on your roof or car. Focusing on the efficiency of operations can also have a huge impact on sustainability efforts. By implementing AI and the Internet of Things into the smart gear grid, such as sensors and real-time monitoring systems, energy flows can be optimized and inefficiencies quickly identified and handled. Innovation in storage solutions would also make the implementation of green energy sources much easier. There are some technologies on the horizon, such as solid state batteries or molten salt storage, that could have a huge impact on this. Lastly, having a way to set a goal and track it is needed to commit to sustainability. Having specific targets for greenhouse emissions is a great place to start and something that PG&E is already actively doing. One more thing I wanted to mention that isn't on this slide is just a commitment to local safety in general. With how advanced technology is today, things like forest fires and homes burning down should simply not be happening. Drones and AI powered sensors can be used for real time monitoring and early detection, something which I hope to see more of in the future. Lastly, let's take a look at some specific corporate social responsibility actions PG&E can take today. So, what are some specific corporate social responsibility actions PG&E could be taking now? Empowering local communities is a great step in the right direction, which can be done by encouraging development for local solar or wind projects, or even offering specific incentives for energy efficient practices. An example of this could be some type of reward for installing energy efficient appliances or light bulbs. Being more engaged with stakeholders could also have a huge impact on the problems that PG&E is facing today. By collaborating with major clients on upcoming plans and projects, PG&E could more effectively plan for the future and work with local agencies to be more efficient in their energy goals and needs, being proactive rather than reactive as we've seen they are in the past. Another is promoting energy education. Through public awareness campaigns or working with local schools, just getting the word out in general about the benefits of renewable energy and responsible energy usage could have a huge impact and also shift the public focus towards those goals as well. Being ethical, kind of a no brainer here, but more specifically, being able to address the supply chain issues and delays with transparency and dealing with problems more efficiently. Again, just being more proactive about the issue rather than reactive. Lastly, as we mentioned on the previous slide, you need to have a clear goal and way to track it. One way to help overall energy efficiency could be to start tracking and reporting on decreased usage or improved energy efficiency for both households and businesses. Being aware of the problem is always a great first step in solving it. Well, that concludes our presentation on the PG&E power grid, the supply chain and other issues it faces now and in the future, and potential plans and actions that can be taken to solve these problems and work towards a sustainable future. Thanks.